Welcome, everybody. Thanks for joining us for the next presentation from Newell, Washburn. Newell is both associate professor at the Carnegie Mellon University and also founder of Ansatz AI. And today he will tell us about design and optimization of liquid formulations by hierarchical machine learning. Newell, with that, over to you.
All right. Well, thanks. I appreciate the opportunity to come tell you about the work that started at Carnegie Mellon and is translated over to a separate company, Ansatz AI. Ansatz was founded by myself and Barnabas Pakchos, who's my colleague in machine learning at CMU. The focus has really been on design and optimization of complex chemical or material systems using machine learning. We've developed really a family of algorithms that are intended for smaller and primarily experimental data sets. I'll talk a little bit more about what specifically we do at Ansatz toward the end of the presentation. There are two types of problems that we seem to encounter in the chemicals and materials industries. One is continuously providing a tailored solution. So, for example, color is something that we work on. And here you may be looking for to change the color or adjust the color of a coating, for example. And the goal is, and you're continuously doing this, and we'd like to get the cycle time from weeks to days, or days to hours, or even minutes to seconds. The other is just optimization of very complex material systems from small data sets. And here, really what we're trying to do is get modeling where the algorithms are learning from tens of samples, not thousands. Traditional approaches to these, so not machine learning, have really been kind of based on intuition. They're highly iterative. And really the goal in machine learning is to do a comprehensive and integrated optimization of the three types of variables that we have. So process variables, formulation variables, and chemical variables. So I'm going to mostly be focused on formulation problems in this seminar. We do other work on molecular design and also process optimization, but increasingly formulations are becoming a focus for us. So in particular, liquid formulations are multi-phase fluids that have complex rheological characteristics and a variety of functions. So these include, paints, personal care products like shampoo, pesticides, etc. Collectively, these are all very large industries, and really across all of them, cost, sustainability, and performance all seem to be sort of common drivers at this point. So what makes designing liquid formulations so complex is partly the number of ingredients. So we've got a solvent, you'll have dispersed phases, surfactants, dispersants, viscosity modifiers, things like that. And so you've got even just listing the components, you have a high dimensional problem, but then it gets further complicated by all the interactions between these different constituents. And so this becomes a very complicated design and optimization problem that is traditionally been done strictly by people. But the problem is again, these approaches for optimization really are iterative, based on experience, and really rest on sort of general rules for things like compatibility. So, what solvents and what dispersed phases would go together, for example. So in terms of the R&D development cycle for these liquid formulations, I mean, in general, this looks sort of a lot like most other formulation problems. So we're going to define our characteristics, our functions. So in this case for shampoo, I want to clean my hair. I want to have a certain lather, things like that. I have a list of ingredients that I'm going to be working from. I will then make test formulations and then measure their attributes before I make some adjustments and go back to and looking at the product functions. So what looks like, while it may look to us when we go to a store to buy paint or shampoo or anything else, what may look like a fairly static product is actually constantly changing due to new product requirements. So maybe increases in performance, switches